In this edition of lecture, we will analyze the topic of refraction of chapter light. So earlier we understood the different magnification formation in convex and concave mirror. So what is the refraction? So in the daily life, you might have been observed many times that a scale are partially submerged in water is observed as a bent inside the water. And similarly, a coin or the other object inside the water tank is seen at higher level and nearer our eyes than its actual depth. You might also have observed that when a glass paperweight is placed over a written sheet, then the word below the paper weight looks higher in level in comparison to the rest of the words of the sheet when viewed from the upside. So why is it happen in our everyday life that a pencil partially visible, when it's submerged in the water, it is partially bent. It looks like a partially bent. So the reason for seeing the partially submerged object as a bent is that the direction of a light rays from the object out of water and from the object submerged in water is different, and because of this submerged part looks a bit higher in level. Yes. For example, the light source is coming from the one medium to another medium. It means from air to water. And due to light is going from the air to water, so there is a little deflection happen as compared to when the light is fall on the object, which is deep under the water. And when the light is coming, see this diagram, when light is coming after reflecting on a particular pencil in the water, so it looks bent. Why? That is the X. That is a real line of pencil, and that is why that is a bent image. Why does it happen? Due to refraction of light. When the light is going from one medium to the another medium, it happens due to the refraction of light. So by performing a simple experiment, you can observe the change of direction of light rays in a beaker or a small container. Put a coin and now adjust the container with respect to your eyes, and such that the coin just become invisible to your eyes, and now pour water or ask your friend to pour water on it. So there are some daily life based experiment that why coins are looks in upright direction when we put in the water, and the reason is then when light travels from one medium to another medium, then at the plane of separation of both the medium, the direction of light rays changes. And this effect is known as refraction effect, where the light is coming from air to water. So there is a small deflection of the light rays which change as compared to along with the medium. So that is the main reason the why pencil looks bent and why coins look upward direction. So that is a diagram which shows that why coins looks like a upper side. Okay, that is a real image of coin, and that is a virtual image we see. Okay, and coin is seen here. We see coin here, but the actual location or position of coin is here, and that is the water. And when we see from the upper side, it looks here. Why? Because due to refraction of light. Because light enters from the air to water. And when light enters from the air to water, it means the light is deflect from its path. The light is deflect from its path. And that is why it looks upper side. Okay. Because we see as a parallel line. But when we see from the exact upper side, 90-degree angle, it looks like the coin is beneath. The surface. So that is the beauty of science and experimental science. So the velocity of light in vacuum is 3 into 10 to the power 8. Okay. What is the velocity of light? That is the velocity of light is 3.8 3 into 10 to the power 8 meter per second. And when the light reflects from one medium to another medium, then the velocity is change. Glycerin, water, glass, etc. are denser with respect to air. What? Water, glass, glycerin, these are denser with respect to air. And air is rare medium. Okay. So light enters from the rare medium to the denser medium. If the second medium is denser relative to the first medium, then the velocity of light will be relatively less in denser medium, while the frequency does not change. Yes. Velocity of light can be changed when light enters from the rare medium to denser medium, but frequency does not change. That is why, because of this, while going from rare to denser medium, the light rays bend toward the perpendicular. It bent toward the perpendicular. On the contrary, when light travels from denser to rare medium, its velocity increases. Okay, when light travels from denser to rare, means from water to air, the velocity is increased. And when light travels from rare to denser, means air to water, the velocity will be decreased. Why? Because water is a denser medium and it restricts some, and it is able to restrict or stop some kind of intensity of light. So here density's strict sense is optical density. So that is this diagram shows the how refraction takes place. So that is the incident ray, and one is normal ray, and that is a rectangular glass slip. That is the incident ray, P to O, and that is a refracted ray, that is O to O dash, that is a refracted ray, and that is a normal line N, and that is the angle of incidence, that is between Q to O, that is angle I is formed, that is called angle of incidence, and that is angle of R, refracted R, okay, between S to O. And when the light enters from air, that is rare to denser, that means glass is a denser medium. So what is the velocity of light when it enters from air to glass or rare to denser medium? Yes, the velocity of this become decrease, because in denser medium the intensity of light is decreased, so the velocity is also decreased. So what is the formula of refraction? If we want to suggest what is refraction, that is in refraction the ratio of sine of angle incidence, that is angle I, and sine of angle of refraction remain constant. So sine I equal to sine R equal to constants. So this is the second law of refraction, that is also known as Snell's law. What is Snell's law? That is sine 21 or mu 21, it means 2 1. It means medium 2 with respect to medium 1. Okay. So sine I equal to sine R, that is angle of incidence is equal to the angle of R. They are constant in medium. So how we calculate the speed of light in medium? The speed of light in medium, that is air, that is V1, and the speed of light in medium 2, that is V2. That is how we can calculate the refractive index of speed of light in air and speed of light in water. That is medium 1 is air and medium 2 is water. In the next edition, we will analyze the total internal reflection done by the nature.